Hello and welcome. Today's lesson is going to be about bisectors of triangles. There are two types of bisectors, the perpendicular bisectors and the angle bisectors. And these are going to be our objectives today, to learn about both of them. First of all, let's talk about some vocabulary words. They are concurrent and point of concurrency. Okay, whenever you have three or more lines, rays, and segments that intersect in the same point. For example, here in this drawing right here, we have three lines that intersect in the same point. Then we say these lines are concurrent to each other. And we also say that this point right here where they meet, where they intersect, is called the point of concurrency. Now let's talk about perpendicular bisector. If you remember perpendicular bisector, perpendicular means that it forms 90-degree angle, and bisector means cuts right in the middle. Okay, so right here on this diagram, I have this line right here, CD, that is forming 90-degree angle with segment AB, and it's cutting right in the middle because I see that AD is the same as DB. So that means CD is the perpendicular bisector of AB. So remember, perpendicular bisector could be a segment, a ray, a line, or plane that is perpendicular to a segment at its midpoint. So in this case here, I have this line, and it's the perpendicular bisector because it's perpendicular at the midpoint of AB. All right, now let's talk about two theorems here, or one theorem here called perpendicular bisector theorem. Basically what this theorem says, if you have a point, any point on the perpendicular bisector of a segment, that point right there, so right here I have a point C, is on the perpendicular bisector, that point is equidistant to the endpoints of the segment. So in other words, these two are congruent. Okay, that's basically what the theorem is saying. So if you have a perpendicular bisector, any point on that perpendicular bisector is equidistant. So in this drawing, I was able to draw these two things because I know that this is the perpendicular bisector. Okay, so I was able to reach that conclusion because the perpendicular bisector of AB. All right, now let's talk about the converse. The converse, if you remember, is when you switch the hypothesis with the conclusion. So basically, what I have here is, let's say I have a point that is equidistant to the endpoint of a segment. So basically, I know that this distance is the same as this. So that means this point, if I was to draw a perpendicular line going through this point and perpendicular to the segment, this line here would cut the segment right in the middle. So that means I could add these to the drawing. And basically, that's what the converse is all about. Because I know that these two are the same and I have a 90-degree angle, these two are the same. So let's look at some examples here. Find the measure of FM. So basically, I'm looking for this segment right there. Using my geometric eye, I see that this is a 90-degree angle, and I see that this line right there, or this segment here, is cutting this right in the middle. So in other words, this is the perpendicular bisector. So that means that point F is equidistant to these two points right there. So that means that these two lines are congruent. Fm equals 2.8. In this particular problem, on the drawing, I only see a 90-degree angle, but I don't know anything else about the drawing. But if I read over here, it says that BD is the perpendicular bisector of AC. So that means because I have the word perpendicular bisector, I can come to this drawing and add this to the drawing. And if I do that, I'm able to find the value of x by setting up an equation. 5x minus 6 equals 3x plus 8. And to solve this, all you have to do is cancel the numbers. So we're going to cancel 3x, and we're going to cancel 6 on both sides of the equation. And that means you left with 2x and 14. Divide that by 2, x equals 7. So please notice that this particular problem is very easy. All you have to do is write the answer. This one you do have to show the work to get to the answer. So here I have this drawing, and I see a perpendicular bisector because I see the 90-degree angle, and I also see that these two sides are the same. Okay, I don't see the tick mark, but I do see the 5 and 5. And because I see that, then these two must be the same, because any point on the perpendicular bisector is equidistant. So that means these two are the same. And therefore, the answer is XW equals 7.5. Letter B, we're looking for BF. And if you notice right there, I see that these two are 19. So that means they are congruent. I see a 90-degree angle. So therefore, these two sides must be the same. Okay, so basically that's the whole idea of these problems. Okay, and so we can conclude BF equals 4.2. Now let's talk about perpendicular bisector of a triangle. Okay, a perpendicular bisector of a triangle is the line that passes through the midpoint on the side of a triangle. So if you notice right here, I have this segment right here is GD, and I notice it makes a 90-degree angle. Okay, and not only that, it's cutting right in the middle of the side of the triangle. So that is a perpendicular bisector. Also, EG is a perpendicular bisector. I see the 90-degree angle, and I see they're cutting right in the middle. And so same thing with GF. Okay, so basically DG, EF, and FG are perpendicular bisectors of the triangle ABC. All right, we're also going to learn a new word called the circumcenter. Circumcenter is the point of concurrency of the segment bisectors of a triangle. So basically, whenever all those three segments right there, the perpendicular bisectors meet, remember when three lines meet or three segments meet, that's called the point of concurrency, and that particular point has a special name, circumcenter. That's where all the three perpendicular bisectors meet. Okay, and the property that this point has is whenever they meet, if you draw a line from the vertex of the triangle to that point of concurrency, that segment will be the same if you draw from any of the other vertex of the triangle. So basically, if I have this circumcenter and this segment here from the vertex to the circumcenter will be congruent to this one and to this one, I can conclude that these three are the same. And let me use 4 tick marks. So 1, 2, 3, 4. 1, 2, 3, 4. So basically this, and this are the same. So let's look at some examples. So here it says point P is the circumcenter of the triangle EMQ. So EMQ. List any segments congruent to each segment below. So I'm looking for a segment that is congruent to MY. So this is MY, okay? And this is EY. And if you notice right here, this is the perpendicular bisector because I know that this is the circumcenter. So if you notice right there, you have the three perpendicular bisectors meeting and forming the circumcenter. So guess what? I know that this will be the same as this one. I know that these two are going to be the same. And this one will be the same. I also notice that here we have this line here that is meeting right at the circumcenter. And that line is connecting the circumcenter to the vertex. Okay, so all these red lines right here will be also congruent to each other. So that's the properties that I know because This is talking about circumcenter. So with that being said, when I look for MY, which segment is congruent to MY? Well, EY. Okay, so I can say that is going to be EY. And please also notice that you can write EY or YE. They are both the same. Let's talk about MN. So MN will be congruent to NK. So, and also remember, you can write NK or KN. And then we're looking for KP. So K and P. In this case, there's two lines that are congruent to that. It could be EP or MP, or you can write PM or PE. Okay. The reason why I'm showing this is because sometimes you have multiple choice questions and they could come this way or this way. So it all depends on how the problem is shown to you. Okay, last one here is ER. So ER is congruent to RK, or you can say KR. All right, let's go to the next part of the lesson. So we talked about perpendicular bisectors. Now let's talk about angle bisector. Angle bisector could be a ray or a segment that divides an angle into two congruent adjacent angles. Right here, BF is the angle bisector, because you can see that these two angles are congruent. We have some theorems that relate to angle bisector. So angle bisector theorem says if a point is on the bisector of an angle, then it is equidistant to the size of the angle. So basically, if I have a point on the angle bisector, they will be equidistant. That means the same distance to both of the lines. Okay, that means you need to have the 90-degree angle, and this distance will be the same. And vice versa. If you have a point in the interior of an angle, and you know that they are equidistant to each other, then you can conclude that these two angles are the same. So basically here, if you have the angle bisector, you know that they are equidistant. And if you have a point that is equidistant to two sides of the angle, you know that that point is right on the angle bisector of the angle. So let's look at some examples here. MR is the angle bisector of MP. Find the value of x if angle 1 is 5x plus 8 and M2 equals 8x minus 16. If you remember, angle bisectors cuts right in the middle. So that means we can set up angle 1 equals to angle 2. We set up the equation. All we have to do is cancel the numbers, and we're left with 3x equals negative 24, and then to get the x alone, divide both sides by 3, and the answer is x equals 8. Next one, I have this drawing here, and I see that point E is equidistant to both sides of the angle. So that means, guess what? I know that this segment right here is the angle bisector. So that means I can say that this angle is congruent. So this would be 43 degrees. So my answer is 43. On the next one, I see that these two angles are congruent. So because they are congruent, I can make the conclusion that these two are the same. That means I can set up the equation. I solve the equation for x. And please be careful. Sometimes in geometry, you solve for x, but we're not looking for x. We're looking for mk. So basically, I'm going to take this x that we found. We're going to plug it in. What is the value of mk? Will be 19. So basically here I see these two symbols that they are equidistant, and I'm able to conclude that the angles are the same. Here I see these two angles are the same, and I see the 90-degree angle, so that means I can conclude that these two sides are the same. Next problem, I see these two sides being the same. Notice that I don't have the tick marks, but I do have the value. So I know that these two are the same, so that means the angle is 47. Next one, I see these two sides being equidistant, so therefore I can conclude that these two angles are the same. So I can set up the equation, cancel the numbers on both sides, get 4x equals 16, divide both sides by 4, x equals 4. Now remember, we're not looking for x, we're looking to find the value of EWL. So basically 7x plus 5, we plug it in the x that we found, and the final answer is 33. Just let's say you have a triangle with angle bisector. So here's the angle bisector, here's another angle bisector, and here's the third one. So the angle bisector, whenever they meet, remember, if you have three segments that meet, that means that's the point of concurrency. Well, that point of concurrence is called incenter, the point of concurrence of the angle bisectors of a triangle. So whenever angle bisectors meet, that's called the incenter. And the property is, if you are to draw the perpendicular distance, that means I'm drawing a line or a segment that is perpendicular to the side of the triangle and is touching the incenter, and I draw that to every side, okay? Please notice this is not the perpendicular bisector, because as you can see, this segment here is much smaller than this one, okay? This is the perpendicular distance of the incenter to the side of the triangle. The property of this is that these segments, all these distances are the same. They are congruent. So whenever you have an incenter, the perpendicular distance is congruent. So here we have this drawing, okay, and we know that point U is the incenter, and we're asked to find different values on this triangle. So let's look here for a second. We know that this is the incenter, so that means that this must be the angle bisectors, because the line or the segment that connects the vertex to the incenter, they are the angle bisectors. So that means I can say that these two angles are the same. So in other words, this is 28. I also can say that these two angles are the same. So that means this would be 21. Also, I notice that this here is the perpendicular distance of the incenter to the side of the triangle, and that measurement is 5. So that means this here 2 is 5, and this one here is 5. So let's look at some of the questions that they're asking. Okay, MU. So I'm looking for MU. Well, we know now right there that MU is 5. So, and then we're looking for PHU. So PHU, that would be 21. We found that. And then we're looking for UGM. UGM, that would be 28. And the last one is HU. So HU. So we're looking for this side right here. But if you notice, this is 90-degree angle, so I know that this will be a 90-degree angle. I know that this is 5, and I know that this is 12. So guess what? I can use Pythagorean theorem. A squared plus b squared equals c squared, or you can say c squared equals a squared plus b squared. Either way is fine. So basically, we have the hypotenuse here that we don't know, so we're going to call it x. We have one of the legs, which is 5, so 5 squared, and the other leg, which is 12 squared. Now all I have to do is 5 squared equals 25, 12 squared is 144. We have 169. Please remember, to get rid of the x squared, all you have to do is take the square root of both sides, and we get x equals 13. That's the answer that we're looking for. So that concludes the lesson for today. Today we talk about angle bisectors and perpendicular bisectors. The key information is that the angle bisectors, the point where they meet is called the incenter. And if you draw the perpendicular distance to the incenter, they are congruent. And perpendicular bisectors, whatever they meet in the triangle, okay, that point that they meet is called the circumcenter, and the distance from the vertex to that point, they're all congruent. So that concludes the lesson for today. Thank you very much for your time. Have a great day. Bye bye.